prove that we can write this problem. Prove that cos x has a minimum value of 1 at the point x equal to 0. Okay. So the problem is we need to prove that the cos x has a minimum value of 1. So the minimum value 1 at the point x equals 0. So how to prove this? So to prove this, take f of x equal to cos x. So we know that the maximum in our problem, at a maximum or minimum, the first derivative is 0. That is the critical point. Okay. So the critical point is given by, we already studied that the critical point is given by f dash of x equal to 0, right? F dash of x equal to 0. So it's over x equal 0. So f dash of x equals 0 means that implies d by dx of cos hx equal to 0. That implies d by dx of cos hx is, so we are doing this for finding the critical points. Okay, d by dx of cos hx equals 0 is sin hx equal to 0. What are the points of x such that sin hx equals 0? Sin hx equals 0 means that e power x minus e power minus x divided by 2 equals 0. That means e power x minus e power minus x equals 0 because multiplying these two here. So this implies e power x equal to e power minus x, right? So this implies when we can say that e power x equal to e power minus x. So this is only when x equals 0, or we can write like this: e power x by e power minus x equal to 1. This is only if e power 2x, e power x into e power minus x is e power 2x equal to 1. This is only when x equal to 0. So the only critical point is x equal 0. So the maximum or minimum occurs only at the point x equals 0. So now f double dash of x is equal to what? F of x is equal f dash of x equal to sin hx. So f double dash of x equal to d by dx of sin hx. This is nothing but cos hx. Now the critical point is x equals 0. Therefore f double dash of 0 is equal to cos h 0, which is equal to 1, which is greater than 0. Therefore at the point x equals 0, f dash of x equals 0 and f double dash of x is greater than 0. Therefore f has a minimum at x equal to 0, and the minimum value is what? F of 0, which is nothing but cos h of 0, which is equal to 1. So f of x equal to cos hx has a minimum value of 1 at the point x equal to 0. A simple question. Now in this section we can do some other problems which are the antiderivatives or integrals. Okay. Suppose Q7. I think the number of questions is mistaken, but no problem. Okay. Compute the integral. The question is compute integral sin h of 3x plus x cube into dx. Simple question. This is simply this is equal to integral sin h of 3x dx plus integral x cube dx by some formula, so or some rule. So this is equal to integral of sin h 3x is cos h 3x divided by 3. So this is integral plus derivative of x cube is x power 4 by 4 plus a constant of integration. Simple. Okay. Then next one is question number 7, I think. So 7, 8 or question number 8. Evaluate or compute the integral. Evaluate integral tan h x dx. Actually, we didn't find the integral of tan x. Okay, we find the derivative of sin h x. Derivative of tan h x is equal to sec h x. So integral of sec h x is equal to tan h x. But how to find the integral of tan h x? How to find the integral of tan h x? Okay, this simply we can find this integral of tan h x dx is equal to we can write tan h x as a quotient function sin h x divided by cos h x. This is integral sin h x divided by cos h x dx. So here is sin h x and here is cos h x. If you take this as u, the derivative of cos h x will be sin h x. So here is also the derivative. So we can put what? Substitute. We can use the substitution method. Put u equal to cos h x. Therefore, du equal to sin h x dx. Right. So this integral can be written as 1 by u. Cos h x is 1 by u. Sin h x dx can be written as du. So this is nothing but ln u. So replacing ln u ln of cos h x, we can write this directly. So this is plus constant of integration. Okay. Then next one. So next one more question. With this question we can stop our discussion here. The last question. The question is evaluate or compute integral sin h x by sin h x divided by 1 plus cos h square x dx. Okay. How to do this? Sin h x divided by 1 plus cos h square dx. Here is sin h x and here is cos h square x. So to this or to solve this, here is sin h x divided by 1 plus cos h square x dx is equal to. So suppose we are putting in a, like this, here is cos h square is sin h x. So put u equal to cos h x. So du equal to sin h x dx. So we can replace sin h x dx by du and cos h square x by u square. So this will be integral 1 by 1 plus u square. So we are replacing cos h x by u. So here is 1 by 1 plus u square and sin h x dx will be du. So this is du. So we know the integral of 1 by 1 plus u square, which is tan inverse of u, right? Tan inverse of u plus constant of integration. Now we can replace u by cos h x. So tan inverse of cos h x. Tan inverse of cos h x plus a constant of integration. Okay, now I am giving a homework for you. Question number 10. Compute integral cosec square x dx. Simple question. How to solve this? How to compute this? Yes. A hint can be given to this. We can use the half angle formula, because what was that? Cosec square x is equal to cosec 2x plus 1 divided by 2. So you can directly integrate that. So thanks for watching, and see you in the next video. Okay, thank you.